Hello everyone. In this video we're going to be solving a nice functional equation from a mathematical magazine, Crux Mathematicorum. If I can find some links, I'll share them down below. So we have f of x plus 1 over f of x equals x squared plus 1 all over x, and x is given to be positive. I think some of you already figured it out at this point, but let's proceed. I'll be presenting two methods. And let's start with the first one. Actually, I changed my mind. Let's start with the second one. For my second method, I'm going to go ahead and replace f of x with y. And you probably know y, right? So from here we get y plus 1 over y equals x squared plus 1 all over x. Now, since I'm going to try to solve for y, because that's my goal, I'll treat x as a constant. So x is a constant for now, okay? Let's go ahead and set the whole thing in terms of x equal to c, okay? Now this is going to make the solving the quadratic a little easier. So multiply both sides by y. You're going to get y squared plus 1 equals cy. And then you'll get y squared minus cy plus 1 equals 0. So this is quadratic in y, and we're going to solve for y. And you're like, why? Okay. This is, to solve this problem, we're going to use the good old quadratic formula. So and here's how it goes. Y equals negative b plus minus the square root of b squared, which is c squared, minus 4ac, which is minus 4. All of that is divided by 2. Awesome. That was easy, right? But we kind of need to back substitute c. What is c? C is x squared plus 1 over x. This one, right? So let's go ahead and do that. And I can basically look at the discriminant first. Let's simplify the discriminant. When things get complicated under the radical, you want to kind of isolate it, simplify it, and then once you get a simple expression, you can just plug it in instead of writing that complicated expression every time. Make sense? So that's kind of like a nice strategy, save some time. So we're supposed to evaluate the discriminant, which is c squared minus 4, but c is x squared plus 1 all over x. I'm going to have to square this and subtract 4 from it. I know what you're thinking at this point, but let me finish this up. If you square the numerator, you get x to the 4th plus 2x squared plus 1. If you square the denominator, you get x squared. And if you subtract 4 from it, what happens? There's a couple of ways to approach it. I'm actually going to make a common denominator and write this as x to the 4th plus 2x squared plus 1 minus 4x squared all over x squared. And now these two are like terms, right? They like each other. We can go ahead and combine them. X to the 4th minus 2x squared plus 1 all over x squared. And does that look familiar? If you said yes, that's great, because this is x squared minus 1 quantity squared in the numerator, and at the bottom we have x squared. And they're both perfect squares, and that's just perfect, because now we can kind of write this as the square of a quotient. You know the rules, right? Hopefully, the exponential numbers. So we can kind of divide the bases and then use a common exponent, which is 2 in this case. And guess what? At this point, I'm going to go ahead and split it up. You're like, why didn't you do this before? I know what you're thinking. But I wanted to keep it as a secret, okay? Forgive me for that. Now, so we basically got this quantity squared. That is the discriminant, remember, right? So we're going to go ahead and rewrite our equation. What was our equation? Y equals c plus minus the square root of c squared minus 4 all over 2. But now c is equal to x plus 1 over x, and discriminant is this one. Awesome. Let's go ahead and plug it in. Replace c with x plus 1 over x, because that's what it is, remember. Plus minus. Now when you square root the discriminant, the square is going to disappear, giving you x minus 1 over x with a plus minus sign. But I already have the plus minus sign, so don't worry about it. It's all good. Now this is our y, right? And think about y. So now we have two solutions. Let's go ahead and split them up. We can write the plus 1 first, the plus x minus 1 over x divided by 2. 1 over x cancels out. We get 2x divided by 2, which is x. Awesome. That's one of the solutions. Is that a surprise? Okay, the second one is actually the x plus 1 over x. Subtract x minus 1 over x divided by 2. Here the x's cancel out. 1 over x minus 1 over x, and double negation. It's going to be 2 over x divided by 2. You're going to get 1 over x. Wow, amazing. We were looking for f of x, and y is f of x. You know that, right? So we can go ahead and back substitute f of x equals x, or f of x equals 1 over x. There are basically two solutions to this equation, and these are going to be the solutions. Are there any other solutions that we didn't talk about? Something to think about, right? But let's go ahead and go over this, because there's a couple other things that I need to show you, including the first method. So remember, we started with the second method, so the first method will be presented second, but it's still the first method in my opinion. Anyways, we have f of x plus 1 over f of x equals x squared plus 1 all over x. Just disguise the problem a little bit. Now we're going to go ahead and set the same thing, set f of x equal to y, and then you're going to get the same thing, y plus 1 over y equals x squared plus 1 all over x. Now, since the right hand side is kind of like a fraction, I want to turn the left hand side into a fraction too, and kind of write it as y squared plus 1 all over y equals x squared plus 1 all over x. Now, do you see from here that y equals x is definitely going to work? Yes, so it's kind of easy to see one of the solutions. The other one is not that easy to see unless you manipulate this expression a little bit. And you can, obviously, right? You can take out a y squared, so on and so forth. Anyways, let's forget about it and get back to this. Now, what I'm going to do next is actually just an amazing strategy, which is called cross multiplication. Did you know that? It's really fun. Let's go ahead and cross multiply y squared plus 1 by x equals y by x squared plus 1. I know by sometimes is used for division, I think, but I meant multiply by. Anyway, so we're going to go ahead and multiply xy squared plus x and then x squared y plus y. And let's put everything on the same side. I want to put these two together because they're kind of like, I don't know, they seem related to me, right? In terms of factoring. So from a factoring standpoint, they are related definitely, right? So now we're going to find a common factor and factor this by grouping. Factor out an xy, you're going to get y minus x. In order to make this conform to that standard, let's take out a -1 and you'll get a y minus x inside. So we wanted to negate it so that we could get a common factor. That's what I mean by conform, whatever that means, right? And then y minus x is a common factor. Take it out, pull it out, whatever, and then you'll get the other factor, xy minus 1 equals 0. Very different, right? I mean, don't you think? We're kind of solving an equation, but we're kind of not looking at it from a quadratic perspective, but more like, let's just solve the equation. I don't care, right? Now from here, obviously, y minus x, if you set it equal to 0, you're going to get y equals x. If you set the second one equal to 0, you get xy equals 1, but that just means y equals 1 over x. Of course, x should not be 0 in this case, so on and so forth. But basically, this is going to give you both solutions. Different method. Now is the time to look at something amazing, and that's the solutions, of course, from Wolfram Alpha. Wolfram Alpha can find the solutions exactly the same thing. Great. And this is the best part, graph of this relation. If you graph it in Desmos, or I guess I use Wolfram Alpha here, you're going to realize that, hey, this is the graph of y equals 1 over x and y equals x together. And isn't that amazing? And this brings us to the end of this video. Thanks for watching. I hope you enjoyed it. Please let me know. Don't forget to comment, like, and subscribe. I'll see you next time with another video. Until then, be safe, take care, and bye-bye.